What is it? 6, 4.
Okay, we've covered Kramer's rule for using equations or solving matrices, solving systems of equations using matrices. Today we will cover matrix inverses and we will cover reduced row echelon form. You might want to remember those initials RREF, but we'll cover matrix inverses and reduced row echelon form today. Like I said, there's a lot to cover, so you might want to make sure you're keeping up. When we're talking about inverses here, we're talking about multiplicative inverses. And with that idea, kind of like similar to what you used to do on a number, like if I said 2 times 1/2 is equal to 1, then I'm saying that 1/2 is the multiplicative inverse of 2. Because when you multiply those two together, we got an answer of 1. Well, when you multiply two matrices together and you get, say, the matrix equivalent of a 1, which is that identity matrix, 1, 0, 0, 1, or 1, 0, 0, 0, 1, 0, 0, 0, 1, you would have inverses. So the rule is if matrix A times an inverse, or what could be the inverse, or the inverse times A is equal to the identity matrix, which again, up on the board, or knowing that you should have gotten that from the quiz, so on and so forth. And this can only happen with square matrices. You can only do inverses with square matrices. Take these two matrices, and I've got a 3 by 3 here times another 3 by 3. We'll say the first one is A, the second one is B, and type them into the calculator and multiply them. Then see if, when you say A times B or B times A, do you get an answer of 1, 0, 0, 0, 1, 0, 0, 0, 1? The identity matrix, correct. If you multiply those, then yes, they are inverses. If you get that as an answer, yes, they are inverses. If they don't, they're not inverses.
That's how you get that.
No. The point is, we're trying to decide, are these two matrices inverses of each other? Do we get that as an answer? So the key there is just to straight multiply.
So if you've got that.
Or to solve equations. The idea here is you have to know first off how to type in a matrix as an inverse, or to find the inverse of a matrix. If you take any matrix, or take anything and raise it to the -1 power, you get its inverse. In this case, if I take this 2 by 2 matrix that says -2, 2, 3, -4, and raise it to the -1 power. And again, to do the raising, use that caret key, a little arrow up key, kind of, and press that. You should see the exponent on your Inspire, or go up to the exponent, type in -1, press enter. And when you press enter, type that into the -1. You should get You should get an answer of -2, -3/2, -1, -1. That's the inverse of the matrix that has -2, 2, 3, -4. Again, not showing you anything. All you have to do is type it on the calculator. It's pretty easy.
What is the point of the
Test
test?
is just to kind of see. You should know how to solve a two-step equation. Okay, we see this. How do we get rid of the -3? And I'll get to why I'm doing this in a second. Get rid of the -3 by adding 3. Okay, so you have 2x is equal to 8. How do you solve for x from there? Okay, divide by 2. Can you give me another way of solving that other than dividing by 2? Yeah, multiply by 1/2. See, when you multiply by 1/2, same thing as dividing. That is, when you multiply by the inverse, it's the same thing as dividing. That's what you're going to do there. Multiplying by, like, say, 1/2, dividing by 2. Notice how those cancel that out, leaving you just x equals 4. Okay, what you're going to do with matrices is something similar. You can't really divide by a matrix, but you can multiply by its inverse. And so that is what you really need on the notes here. We'll create what is called a matrix equation. That will have you say get the coefficient. You're going to create a coefficient matrix times a variable matrix will equal an answer matrix. So that way, if you've got that, you can take the inverse and you should be able to say, solve. Multiply the inverse to the answer. 8, 2x plus y is equal to 1. What are the coefficients here?
Oh, it's 1, 1, 2, and 1.
Okay, so that will be one matrix. 1, 1, 2, and 1. What are the variables we're dealing with?
1, 8.
No. Variables.
Y,
X and Y. There's your other matrix, your X and Y matrix. And then what's your answers?
So you can type it in like that?
No. This is just setup. The answer matrix, the answers here are 8 and 1. Okay, that's the setup. This right here is the setup. Now, according to this, this is like saying like the same thing as 2x. Now, how did I get rid of the 2 here? I multiplied by its inverse. How am I going to get rid of this matrix? Multiply by its inverse. And if I multiply by its inverse on this side, multiply by the inverse on the other side. So what you're really going to do, if you say that's matrix A, the coefficient, the other one's matrix B, you're just going to say the inverse of A times B, and you will have your answer. If you type this in correctly, you should have an answer of negative 715. And again, you see it on how it should look on the calculator. You want that raised to negative 1. You want times here, even though this is a little blurry. Negative 715. Negative 7. The top number will be your x. The bottom number will be your y. And then when we go to 3, x, y, and z. Top number x, middle number y, last number z. No, it's not. Want to think it's hard right now? It will be. But it's not. Okay, any questions on that? Okay, then we can move on to 4-6, reduced row echelon form. You're really kind of doing 2 sections in one today, but it's not that hard. With reduced row echelon form, you want what is called an augmented matrix. All an augmented matrix is like, say, take the coefficient matrix and the answer matrix and put them together as one matrix. And if you do something from the matrix menu called reduced row echelon form, or choose, and it will show up RREF, going with initials, type in the matrix, press enter, you should have your answer. This is the one that when I used to do it, I used to hate this. This one would take me like a full page by hand, usually minimum.
Could you show us?
Not today, I don't have time.
Wait, is there an N or an S?
Okay, so take this example. 6x plus 1y is equal to 9, 3x plus 2y is equal to 0. To rewrite that as an augmented matrix, okay, you're basically copying the number straight across. 6, 1, 9, 3, 2, 0. That's it. Okay, there's your augmented matrix. Now, I put the little dash line between the coefficients and the answers because that's what I was taught. And I guess I'm still in the habit because I did it just like automatic. But what you want to make sure is you want to have it typed in like this, where it has RREF 619320. Now, if I want to find anything on this calculator, where do I go first?
Menu.
Menu. Okay, so you go to menu.
Matrices.
You should have like 1, 0, 0, 1. Then what after that goes like 1, 0, 2, 0, 1, negative 3. Okay, this is another reason for that dividing line. This is telling me this is my x, and that's the y. So x is equal to 2, y is equal to negative 3. Now let's look at, say, 3 equations, 3 variables. Negative 5x minus 4y is equal to 12. X plus z is equal to 3. 4y plus 3z is equal to 10. Now I purposely did this one because I knew I was going to be running short on time, where on any equation you're missing a variable. But what 3 variables do you see overall?
X, Y, Z.
X, Y, and Z. Okay, that means if I want to do this correctly, I need to make sure every equation has all 3 variables. So what's missing in the first equation?
Z.
Z. How could I write it where it showed that it was missing? 0z. So I should have negative 5x minus 4y plus 0z equals 12. What's missing in the second one? Y. So put 0y. 1x plus 0y plus 1z equals 3.
Why negative 5? Oh.
Because that was part of the problem. What's missing in the third one?
X.
There was no yx, but
That's why
x would be better. So 0x plus 4y plus 3z equals 10. Now, that's the proper way that you want to see it.
It has to be in order, like.
For both of them. The first one is matrix inverse. It would be, this is what you would have to type in your calculator. The coefficient matrix, the inverse of that, times the answer. Reduced row echelon form, you would go to RREF, and then type in the augmented matrix. And the first, you can see the dimensions there, what you would have to choose if you were using like that option that lets you choose your dimensions, and then you just press enter, and you've got your answers. Take a minute, do that.
If you put like 1, 0, 1 the first one, and then 5, negative 5, negative 1, 0 the second one, does it matter?
You know, is the top version is when I use inverses. That's the inverse method. The bottom one is the reduced row echelon form
So where
method.
do I go next?
So there's two different methods. Yes. Okay, that's two different methods right there. Either one should get you the same answer. Now, if you got, say, a weird looking answer, and you probably should do this anyway, double check to make sure you typed it in correctly. But yes, you do get some weird looking answer on this. You should get x is equal to negative 13 over 8, y is equal to negative 31 over 32, and z is equal to 37 over 8.
Oh man, I didn't get it.
Wait, how did you find that? No, it's 4 fractions.
Okay, so let me do this again. Let's say the d, x, y, and z matrix. And again, it's just those d matrices. I'll let it go through its play again. You can see how we're putting in the answers in place of the x column, then the y column, and then the z column. Okay, now from there you've got to take the determinant of each one of those. So that means on the calculator you would say dt of the first one. Copy and paste dt of the the second one, but change out the negative 510 and make it 12, 3, 10. And then do the same thing on the y and do the same thing on the z. All four of those you have to take the determinants of. Excuse me. Alright, if you took the determinants of those, these are the answers you get. 32, negative 52, negative 31, and 148. Just taking the determinants of each one of those. Now, to get the answer of x, it's just negative 52 divided by 32. To get the answer of y, it's negative 31 divided by 32. To get the answer of z, it's 148 divided by 32. And if you simplify all three of those, you'll get the answers we got on the previous examples.
Sir, how do you find the dt?
Say 10 through 13, starting on 4-5 on page 29 of the little Practice B workbook. Problem number 10, all the way through problem number 7, you need to show me the setup. Okay, so make sure you know how to set it up, and I'll show, if I get a chance, give you all a second to copy that down. I'll show you what I mean in a second.
Just
1 through 7 on 4-6. Yeah. Well, starting on number 10 on 4-5 till number 7 on 4-6, it'll be just a setup. And I'll show you what I mean. Because tomorrow we'll practice doing it with the calculator, so that should help you get ready for the test. Okay. Everyone got the assignment?
What do you mean on page 29? Like,
Page 29 of the little bitty workbook.
or the workbook and the other page for the textbook?
No, they're both from the workbook. They're just one after the other. Yes?